So let's go ahead and start lesson 4.1, which covers the slope-intercept form of a line, which most people, when they are in algebra class, they kind of appreciate this, learning this way of graphing, because graphing somewhat is a chore, especially when it involves like making a table or looking at intercepts. But when you're doing the slope-intercept form of a line, all you need to graph it is just the equation and knowing how to interpret that equation. Like what does everything mean in that particular equation? So right here we've got the typical y equals mx plus b. Now that's the format of slope-intercept. And let's kind of dissect this a little bit. Now the y, if it's in slope-intercept form, the y is positive, okay, and it's isolated, meaning it's all by itself. That's the only thing that is on that side. The coefficient of x is the slope. So whatever number is with the x, whatever x is attached to, that will be your slope. And then your b, I'm not sure why it's a letter b, but your b is your y-intercept, meaning that's where it cuts through the y-axis. So the steps for graphing a line expressed in slope-intercept form is I would always start with, I would start with the y-intercept. From there, using the slope, figure out the progression of that line. So, and then pay attention to the fact that, whether the slope is positive or negative. Got an equation there. We have an equation that is already in slope-intercept form, and all we have to do is graph it. So let's make sure we understand all the parts here. Right here, the slope, right? The slope equals -2 to 3, and your y-intercept equals 0, 4. I'm just using an ordered pair there. That just means it goes through the y at 4. So if we graph this, there's your y-intercept. That's where you start. Start with your y-intercept, and then using your slope, draw some more points. So our slope is -2 to 3. So -2 to 3 means down 2, right 3. That's what's going on there. So we're going to go down 2. So we're going to go down 2, 1, 2, and then right 3. 1, 2, 3. And there you go. So your slope, for that one, we know that it was negative, and that line appears to be negative. It's going from left to right. It's going in a negative progression. It's going down. It goes through the y-intercept at 4, 0, 4, and it has a negative progression of down 2, right 3. Number 2 is also in slope-intercept form already, so we don't have to do any changing of it. So our slope is equal to 3, but it's sometimes easier to think of it in ratio form, so just think of it as 3 over 1. And then our y-intercept, pay attention to the negative sign that's in front of it. That's our y-intercept. So our y-intercept is going to be 0, -1. Start with that point first. The y-intercept always comes first, and then using the slope, go either up or down from there. So our slope is 3 to 1. So we're going to go up 3, 1, 2, 3, and then right 1. Make a point. And we could probably do this one more time. So up 1, 2, 3, and then go right 1. And if I want to make more points, I can go down 1, 2, 3, and then left 1. I can just do everything opposite. And then there's your line. Now, when you have it in slope-intercept form, it's very, very simple to graph. It's a very nice way of doing it. For number 3, you got a very plain equation there. It's a very simple equation, but it throws people off because it doesn't seem like there's enough information. So let's go ahead and fill in that information that seems to be missing. I mean, it's not really missing anything, but just to your eyes, it may seem like there's not enough there. But if you want to figure out the coefficient of x, well, x is just x, meaning it has a coefficient of 1. It has a coefficient of 1. So you got 1x right there. Now there's nothing added. There's nothing like plus or minus there. But we can put something there that doesn't change the meaning of it. We can put plus 0, meaning that the slope of this, or the graph of this line, goes through the origin. That's where it goes through. So it's going to go through 0, 0 right there. And our slope is 1. And if we think of that as a ratio, that just means 1 over 1. Up 1, right 1. Up 1, right 1. And so that's really easy to graph. Up 1, right 1. And you can make a bunch of points here. You don't have to make as many as I'm making. But we have a pretty good idea now that the graph of the line looks like this. All right, now number 4 is one of those equations where it's like an x or y only. Well, this one's a y only. And y only equations are horizontal. So that is going to be horizontal, and that's going to go through 3. Now, if we want to rewrite that equation so that it does have an x in it, we could. We can write it like this. We can write it as y equals, you can write 0x, and then we don't have a constant, so plus 0. All right, now if we want to write that out in slope-intercept form, it's going to be y equals, and now you might notice, like, obviously there's no x in there, but we can put an x and still mean the same thing. So we got 0x, and then 3 is the constant, so you can just write plus 3, meaning that's the y-intercept, which is true right there. And then right here, this has a slope of 0, meaning for every 1 that it goes up, it goes up 0, it's going right or left 0. So it's not going anywhere. It's perfectly flat. It's horizontal, left to right. Number 5 is our first one where we don't have it in slope-intercept form. So when we want to get it in slope-intercept form, you need to get y by itself. We want to isolate the y. That's what we want to do. Subtract 5x from both sides. And this just becomes an exercise in inverse operations. So you got 2y equals, I'm going to write it negative 5x plus 8. It kind of looks like it's in slope-intercept form at this point, but it's not. It's not in slope-intercept form until that y is by itself. And it's not just a matter of scratching off that 2. In order to get rid of that 2, we're going to have to divide both sides by 2. So we're going to divide everything by 2, because that's the property of equality, and then rewrite it again. So now we have y equals negative 5 halves x, and then 8 divided by 2 is 4. So now it's in slope-intercept form. So there's our slope. Our slope equals negative 5 to 2. And there's our y-intercept. It's going to be 0, 4. Start with your y-intercept, 0, 4. Right here. And then the slope indicates we go down 5, right 2. Now notice when I start counting down 5, we have to go 1, right? That's 1, 2, 3, 4, 5. So that's down 5 and then right 2. 1, 2. So our next point is going to be right there. And never mind my crooked looking lines there when I'm drawing them. But yeah, that will do. For number 6, we have to get y by itself. Again, we need to get y by itself, not x by itself. It's got to be y. So we need to get everything over onto the x side as much as possible. So I'm going to go ahead and subtract 3 from both sides. Now 3x minus 3 is not 0, because those are not like terms. So I'm going to rewrite it. I'm going to write it as 3x minus 3 equals 3y. So you got that, and then to get y by itself, it's a matter of dividing everything by 3. So everything gets divided by 3. Those cancel off right there. And then 3 divided by 3 is just 1, which makes x. Negative 3 minus 3, that's minus 1. And then this is just y. Now if I clean this up and make it look like it's in slope-intercept form, I mean it already is in slope-intercept form, but kind of put everything where you're used to seeing it. You've got y equals x minus 1. So that has a y-intercept of negative 1 right there. And then it has a slope of 1 because the coefficient of x is 1. So our slope is going to be 1 over 1. So that means up 1, right 1. Up 1, right 1. So it's going to follow that really easy progression right there. For every 1 it goes up, it goes right 1. For every 1 it goes to the right, it goes up 1. And then there's the graph of the line right there. Now moving on. All right, so now the next part here, we're going to talk about the property of parallel lines. And for parallel lines, I have some notes already written here. It says parallel lines will have equations with equal slopes. The slopes will be exactly the same, but the y-intercepts are different. So like right here, I've got 2 lines here. Now if let's say I put this one here, and let's say this one right here, this other one is parallel to it. Well, if it's parallel to it, it can't be right on top of it, because then that means it's exactly the same line. They have to have different y-intercepts. So no matter where I put this, it's parallel. So it's parallel here, it's parallel up here, it's parallel even way down here. But in order for them to be parallel, they have to have the same slope, which those lines do, because I basically just copied and pasted the same line that I drew. And the intercepts are distinct. They're totally different from each other. All right, so for number 7, it says determine whether each pair of lines is parallel. What we're going to want to do for this one is, I mean, if you want to, you can graph them, but easiest thing to do is to get them into slope-intercept form and then just compare their slopes and their y-intercepts. You don't have to graph it. If you have a pretty good idea of how slope-intercept works, that's all you need. So the first equation, let's go ahead and fix that up. We've got negative 3x plus 8y equals 24. Let's take away 3x from both sides, or add 3x to both sides. Add 3x, and then I'll rewrite it. Now I've got 8y equals 3x plus 24. And now it's just a matter of dividing everything by 8. 8 divided by 8 is just 1. And then this becomes 3/8x. And then 24 divided by 8 is 3. All right, so there's your equation. So if the other one, when we're all done with that one, if it comes out with 3/8 as a slope, and the y-intercept is any other number but 3, then they are parallel. So let's go ahead and do that. So our next equation was 3x minus 8y equals 7. We're going to subtract 3x from both sides. It's moving stuff around at this point. So now we've got negative 8y equals negative 3x plus 7. Now notice when we move that 3x, that negative is in front of that 8. That negative has to stay there. So it's still negative 8y. And now we're going to divide everything by negative 8. That gets divided by negative 8. Negative 3 gets divided by negative 8. And 7 gets divided by negative 8. And get a bunch of fractions, but this is all we need. This is the story that we need. So we got 3/8. We got negative divided by negative, which is positive. So you got 3/8x. And then minus, I'm going to put just minus 7/8. I could put plus negative 7/8. But that's all the information we need to tell whether these are parallel. And this has a slope of 3/8, and this has a slope of 3/8, and they have totally, completely different y-intercepts. So this means that they're parallel. They're parallel to each other. All right, for number 8, the first equation, y equals 6x minus 2, is already in a form that you like it to be in. So let's go ahead and change the second one. It's already in slope-intercept form. So you got 12x minus 3y equals negative 5. Let's go ahead and take away 12x from both sides. Now for number 8, we've got the first equation is already in the form that we want it to be in. It's already in slope-intercept form. So leave it be. Let it stay that way. Let's go ahead and just focus on that second equation. So we got 12x minus 3y equals negative 5. I'm going to subtract 12x from both sides. And now rewrite it. Got negative 3y equals negative 12x minus 5. And now divide everything by negative 3. Divide everything by negative 3. Those cancel out. So now we have y equals negative 12 divided by negative 3 is 4. So you got 4x. And then a negative divided by negative is positive. So plus 5/3. And the question for this one is, are they parallel? Well, they are not parallel. They definitely have different intercepts, but that doesn't matter. What matters is, are the slopes the same? So for number 8, the slope is 6, or for the first equation in number 8, the slope is 6. And for this one, the slope is 4. So these are definitely not parallel. Moving on, perpendicular lines meet at a 90-degree angle. The slopes are opposite of each other. Positive, that means if one's positive, the other one's negative. If one's negative, the other one's positive. And is in all caps again, meaning that's important. And they're reciprocal of each other. So that means like if you flip it over, reciprocal is when you flip a fraction. And so those two things have to be present in order for them to be perpendicular to each other. So 2/3, the reciprocal of 2/3 is 3/2. So you got 3/2, and then the opposite of positive is negative. So negative 3/2. There you go. Now for this one, the reciprocal of negative 8, if you want to think of that as a fraction, negative 8 over 1 is going to be 1/8. And the reciprocal of a negative is going to be a positive. We don't need to put a plus sign there, but there you have it. All right, so those slopes are definitely perpendicular to each other. Notice there's, in this particular part of our notes here, notice there is no mention of the y-intercepts. The y-intercepts don't matter. Here, what matters most are the slopes. That's what matters most. So let's do what we have been doing, which is get these equations into slope-intercept form. So now that I have the lines in slope-intercept form, now we can just compare the slopes. Now, one slope is 4/3. One slope is 4/3, and the other slope is negative 3/4. Well, they're opposite of each other, so that we can check that box. One is positive, the other one's negative. And the next thing we want to know is, are they reciprocal of each other? And they are indeed reciprocal, because when you flip 4/3, the 4 goes to the bottom and 3 goes on top. So yeah, these are perpendicular for sure. All right, let's do the same thing for number 10. Let's get these equations in slope-intercept form. Okay, so now that I've got both those equations into slope-intercept form, let's just look at the slopes. Now, the slope of the first equation is 9, and the slope of the second equation is 1/9. Now, those are definitely reciprocal of each other. The reciprocal of 9 is 1/9, because it's 9 over 1 to start off with. Flipping that makes it 1/9. However, they're not perpendicular because they're not opposite. So they check off one box, but not both. So they're reciprocal, but one of them has to be positive and the other one has to be negative in some order. Positive, negative, negative, positive. Doesn't matter which one's positive as long as the other one's negative. That's all that has to be there. Okay, so that does it for perpendicular lines and whether or not the graphs of them are perpendicular. Also, another thing I want to add here is that sometimes people think perpendicular means like, here's the coordinate plane, and then here's some perpendicular lines. Some people think, well, perpendicular has to mean like, it has to be like that. One line has to be vertical and the other line has to be horizontal, which is true. That is definitely perpendicular. But perpendicular just means when they meet, when those lines meet. Let's say we have a line going this direction and we have another line going this direction. where they meet is a right angle. So right there, when we zoom in on that, that's a right angle. So never mind whether one is perfectly straight up and down, the other one's perfectly horizontal. What matters most is that angle that's formed by those two lines. Okay, so that does it. All right, see you at the next lesson.